The SN2 is the first reaction we'll talk about. Among the big four, it is probably the most commonly encountered reaction of the big four. What does this look like? Well, we're going to have some reactive anion, and we're going to call this our nucleophile. Why would we call this a nucleophile? Well, it's an anion. It loves nuclei, okay, positively charged things. And this is going to react with some structure, and typically I said we're going to react with alkyl halides, not only alkyl halides, but normally alkyl halides. And so the alkyl halides, if this is a nucleophile, it by definition reacts with an electrophile. And the role of this halide is to be a leaving group. And so the nucleophile, because this carbon is attached to an electronegative atom, the carbon has a partial positive charge, and the nucleophile, which is a strong nucleophile, it sniffs out this partial positive charge on carbon, and this carbon has a full octet. If you're going to make a new bond between that carbon and the nucleophile, we have to break an old bond. And our leaving group, fortunately, is electronegative. It accepts that electron density. And what we get is the nucleophile attached to our carbon, and our poor bromide gets ejected. That's why we call it the leaving group. So this is the basis of the reaction. Energetically, so here's our reaction coordinate, our energy diagram. This is a one-step process. It involves a transition state. There is no intermediate in this reaction. So we have the starting materials and products. Why is this a downhill reaction? It's a downhill reaction because this nucleophile is really reactive. This nucleophile is the dark figure who enters a bar in a Western. And when that figure enters the bar, you know there's going to be a gunfight. There's going to be trouble. This nucleophile is going to cause trouble, and it wreaks havoc on the electrophile. So this is a downhill process. This is the most common of the big four reactions. It's one step. And we'll see there are a lot more features to recognize for an SN2 reaction. But these are the basics. We need a really good nucleophile. We need an alkyl halide that has a leaving group. But the main feature is it's the nucleophile. The nucleophile is what drives this reaction and forces it to occur. If you want to do an SN2 reaction and you don't have a good nucleophile, you will not do an SN2 reaction. So the strong nucleophile is the key feature for the SN2 reaction.